going to look at expansion and factoring with exponents. So just a quick review of algebraic expansion. Of course, you all know how to FOIL. It's the same idea when we're using exponents. So just a quick review, you should do the same on your paper. So we can do the same thing. We can distribute even when we've got exponents. We've just got to remember we can only combine the powers of the bases that are the same. So we've got x and x here. We can do x to the 1/2 plus 3 over 2. That gives us x to the 4 over 2. We're going to keep our coefficient of 2 in front here, and we've got, again, the same base x and x, so we'll add 1/2 and 1/2, we get 1. Again, we'll keep our coefficient of 3, and, ooh, that should be a negative. So there should be a negative in front of here. And when we add those exponents of our same base, we've got x to the 0, right? Positive half plus a negative half gives us 0, so then we can simplify that. Oh dear. This is 2x to the 1 minus 3x to 0. Okay, so we simplify that. We've got x squared, 4 divided by 2 is 2, plus 2x, and then just simply minus 3. Okay, because x to the 0, this is 1. Anything to the power of 0 is 1. Okay, we can expand this next one. We have 2 to the x times 2 to the x. So since it's the same base, we can add our exponents. We have 2 to the x plus x. We've got plus 3 times 2 to the x. We've got plus 1 times 2 to the x, and plus 3. So when we simplify that, x plus x is the same as 2x. So we've got 2 to the 2x. We've got 3 times 2 to the x plus 1 times 2 to the x. We can look at 2 to the x as a variable, basically. So we've got 3 of them plus 1 of them. So overall, we've got 4. 3 plus 1 gives us 4 times 2 to the x. But we still can't combine that. And plus 3. The reality is that's a good answer, and that's fine to leave it like that. If you wanted to kind of be even more neat, realize that we can write 4 with a base of 2, 2 to the 2, right? And we've got 2 to the x. So now we've got the same base, and when we have the same base and we're multiplying, we can add our exponents. So 2 to the 2 plus x, or x plus 2. Okay, so either way, this is fine. This is even kind of more simplified, if you will. Okay, here we're going to square this, so we have to multiply it by itself. So we have 7 to the x plus 7 to the negative x times itself. Okay, first of all, we can't simplify the bracket itself. When we're adding and we have the same base, there's nothing that we can do unless it's exactly the same thing. Like we have here, we have 2 to the x and 2 to the x, so we can add our coefficients. But in this case, we can't combine them at all, so we FOIL. So we have 7 to the x times 7 to the x, and we can add those exponents because we have the same base. So we have 7 to the 2x. We'll have 7 to the x times 7 to the negative x, and we'll add those exponents. X minus x gives us 0, so I'll have 7 to the 0. We'll do the same with our outer ones, 7 to the x times 7 to the negative x. Again, when we add positive x and negative x, we'll get 0. And we've got 7 to the negative 2x. Okay, so we've got 7 to the 2x. 7 to the 0 is 1, so we've got 1 plus 1, which is 2, and 7 to the negative 2x. It's nice not to leave negative exponents in our solutions, so we can write this as 1 over 7 to the 2x. Okay, by the way, another note, again, this is a great solution. If you want, in either of these cases, see how we have 2 to the 2x or 7 to the 2x. realize that we can simplify that, we can manipulate that even further. I don't know if you could call it simplified. So 2 to the 2x, we can write that as 2 squared to the x. Means the same thing, right? So we could write that as 4 to the x. Okay, and same here, we could write this as 7 squared to the power of x, which gives us 49 to the x. So either way, this is what we've done here is a good solution, but you can totally, just so you recognize that we can write 7 to the 2x as 49 to the x. It's just good for you to have that recognition. Okay, so not only should we be able to expand, but we should also be able to factor. So we've got 3 to the n plus 3 here. We can write this as 3 to the n times 3 cubed. Remember that the rule is that when we're multiplying with the same base, we add our exponents. So you should be able to do the same thing backwards. So if we're adding our exponents, we should be able to take that and turn that into a multiplication problem with the same base. So we've got the exponent of n, we've got the exponent of 3. Okay, plus 3 to the n. So now we can factor out 3 to the n from both terms. So we've got 3 to the n times 3 to the 3. And if we also take a 3 to the n out of here, we have to hold that place with a 1. Okay, for b, again, we're adding our exponents. So we should be able to write 2 to the n times 2 squared. If we do our exponent laws backwards, because here we've got the same base, when we multiply with the same base, we add our exponents. So it's nice to then write 8 as a power of 2. So 8 is 2 cubed. So then we'll factor out what we can here. We can factor out a 2 squared from both of these. 2 squared, 2 to the n plus, if we take out a 2 squared, 2 cubed, remember, is 2 times 2 times 2. So if we take out 2 squared, we're still left with 2 to the power of 1. Okay, so that one's complete. And again, we can't combine this part of what's inside our brackets anymore, because here we've got a 2 to an unknown and 2 to the power of 1. When we add with exponents and the same base, there's just nothing we can do to combine it unless we were to know what that power of n actually was. Okay, here we've got 5 to the 3n plus 5 to the 2n. So again, just because we have the same base doesn't mean we can combine anything because it's addition. So we can write 5 to the 3n as 2n plus 1n, right? 2n plus 1n gives us 3n. And this is 5 to the 2n still. The reason that helps us is then it allows us to factor out 5 to the 2n. So we've got 5 to the 2n times 5 to the n plus 5 to the 2n. We can factor out 5 to the 2n. And this is what we're left with. So difference of squares, when we have two things that are perfect squares and we want to factor them, we're going to get this form, a plus b times a minus b. So we're going to look at this here as a difference of squares. So notice that 9 is a perfect square, right? And 4 is a perfect square. So let's write 9 as the perfect square it is. It's 3 squared. And then again, we have this to the power of x. So actually, it's 3 to the 2. 3 squared is 9, and then it's to the power of x, so 3 to the 2x. 4 is 2 squared. So now we've got, we can write this as 3 to the x squared minus 2 squared. So we've got our difference of squares here. So we can do, when we factor this, we can do 3 to the x minus 2, and we can do 3 to the x plus 2. Okay, this one is in the form of a perfect square. So what we've got here. So notice, by the way, notice that this is what we get when we factor it backwards, or when we expand it backwards when we factor. Okay, so 25 is a perfect square as well. We know 25 is 5 squared. So we have 5 to the 2x plus 4 times 5 to the x plus 4, which is 2 squared. Okay, so when we do this backwards, we've really got 5 to the x squared plus 4 times 5 to the x plus 2 squared. So these are both perfect squares, and what that gives us is 5 to the x plus 2 times 5 to the x plus 2. Okay, and if we do this, if we FOIL this again, 5 to the x times 5 to the x gives us 5 to the x squared. Perfect. We'll have 2 times 5 to the x twice, which will give us 4 times 5 to the x, and then we'll have 2 times 2, which gives us 2 squared, or 4. So we've really got 5 to the x plus 2 squared. So it's important that you're able to recognize both of these forms, a difference of squares and a perfect square. We should also be able to work with just factoring any old kind of trinomial looking exponential equation. So 4, again, is a perfect square. We can write 4 as 2 squared. So we've got 2 to the 2x minus 9 times 2 to the x plus 20. Okay, so we've got 2 to the x squared. We can write this the same way. Minus 9 times 2 to the x plus 20. So instead of having a variable of x, we've actually kind of, if you can think about it this way, we've got a variable of 2 to the x. It's as if we had x squared minus 9x plus 20. We can definitely factor this. We can say, okay, well, that's x minus 5, and that's x minus 4, because when we multiply negative 5 times negative 4, we get positive 20. When we add them, we get negative 9. Okay, so same idea here, but instead of x, we're going to use 2 to the x. So we'll have 2 to the x minus 5, and we'll have 2 to the x minus 4. And again, when you FOIL that, you should get what you started with, so you can always check your work. So that is totally factored. Did I skip one? Okay. So we should also be able to factor and then simplify like we would any rational expression. Okay, we can write 6 to the x as 2 to the x times 3 to the x. Okay, and the reason we can do that, if you think about it, they're both to the value of x, right? So we can write 6 to the x as 2 times 3. 2 times 3 is 6 to the power of x, right? And so we can distribute that x. We're just doing this backwards. Yeah, and now we've got 2 to the x times 3 to the x. So we can factor out a 2 to the x from both our terms on top. And then we can cancel our 2 to the x. So we're just left with 1 plus 3 to the x as our solution. Part B, we've got 3 to the n plus 1. We can write 3 to the n as 3 to the n times 3 to the 1. Got n and 1, and then minus 3 to the n over 3 to the n. Okay, we can factor out 3 to the n from both terms in our numerator. Okay, this is over 3 to the n, and then we can cancel our 3 to the n. 3 to the 1 minus 1 is the same as 3 minus 1, which gives us 2. Okay, so we have 5 to the n times 5 to the 2, because if we do addition backwards with our exponents, we've got multiplication with the same base, and then 5 to the n. This is over 13. Okay, so we can factor out 5 to the n. Okay, 5 squared plus 1. 5 squared we know is 25, so we've got 25 plus 1 gives us 26. times 5 to the n over 13, and we can simplify 26 over 2 because now we've got just multiplication in the numerator. So 26 over 13 gives us 2 over 1, and we're just left with 5 to the n times 2. Okay, so here we want to look at this as a kind of as a quadratic equation, which in this case it helps us to get one side equal to 0. So I like to keep my biggest term positive, so we can move everything else to that same side. So we've got 9 to the x minus 7 times 3 to the x minus 18 equals 0. Okay, and 9 to the x we can write as 3 to the x squared, right? 9 is 3 squared to the power of x. Okay, we can also write this as 3 to the x squared. Okay, and then it's a matter of factoring. Again, you can think about this as, think about your x as being 3 to the x. So like really, we could say this is of the form x squared minus 7x minus 18. And so in your head, you're thinking, okay, what two numbers? Multiply to negative 18 and add to negative 7. Okay, so we know it's going to be minus 9 plus 2. So instead of x, we'll just have 3 to the x. So 3 to the x minus 9 and 3 to the x plus 2 equals 0. So then we can solve each part individually. So we'll say, okay, 3 to what power is equal, or yeah, 3 to the x minus 9 equals 0. We'll solve this, so we'll have 3 to what power equals 9. And I'm sure in your head you can think, okay, 3 to what power gives me 9? X is going to be 2 because 3 squared gives me 9. That power, that x, has to be 2. And here we've got 3 to the x plus 2 equals 0. When we move x to the other side, we get 3 to the x equals negative 2. And actually, there's no solution to this part. There's no way that we can do a positive 3, take a positive 3, and end up with a negative number. Positive 3 to any power is not going to give you a negative number. So for this part of it, there's no solution. Okay, so our only solution is x equals 2.